All right, welcome to your recorded lesson of elements and compounds, and there's mixtures in there as well. Unfortunately, we are just backlogged and we need to get some more information in a short amount of time when we cancel a bunch of classes. So remember, last few classes we went through what are atoms. We talked about how to determine the number of protons, neutrons, electrons, how to find the mass of each of those things, a little bit about the history of atoms. Make sure you're studying that. And also there was like a practice worksheet that you could have gotten. So you'll need to know how to use a periodic table to determine some information about an atom. But today is elements and compounds, and let's dive in. So, here's a picture of Shiloh and I reading one of our favorite books, Quantum Physics for Babies, which I highly suggest for Christmas if you have any little ones on your Christmas list. Here's Shiloh, a little bit more grown up. We went on a hike through a prairie a few weeks ago, and the lighting was just right. It turned out really well. Anyway, this lesson can only be 15 minutes, and then it'll tag it to another lesson. Um, so there will be multiple videos in this particular lesson. But anyway, let's keep going. First off, the elements. Um, you guys probably know what an element is. It's matter that's made up of only one kind of atom. So if you were to look at the periodic chart and you saw helium, guess how many different types of atoms? Oh, here's helium over here. How many different types of helium atoms are there? One. You might say, well, what about the isotopes? Yes, technically that is still helium. It's just helium that's got more neutrons in it. So um, remember that about isotopes. An element is the purest form of a substance. In other words, if you had something like sodium here and you try and break it down into something simpler, you can't. It's going to be sodium. You just can't break it down into anything simpler. Elements, and that's just what I just told you, elements cannot be broken down into simpler substances. You can't do that with calcium or magnesium or beryllium or anything. You can't break it down into a simpler substance. It is in its most simple form. Um, and also, the type of element is determined by the number of protons in the atom. That was a question in your lab not long ago. I said, what if a carbon atom, instead of having 6 protons, what if it had 7 protons? And then you would say, well, it wouldn't be carbon anymore, it would be nitrogen. Each time you add a new proton, it becomes a new element. And then elements are organized by atomic number on the periodic chart. So if you remember part of our history lesson from a while ago, um, atoms were arranged according to atomic mass at first, and then they got rearranged by atomic number. Actually, I think that's a lesson in the future about the periodic chart. Let's keep going. Oh, meet the elements. We'll pause for a second. Here's a video. This is, again, it's kind of juvenile, but it's a song, and if you have to teach anything about elements to your class, this is a great song. It's by They Might Be Giants. Take a moment to watch it. It's not absolutely critical. There's nothing on that video that will be on your test. It's just fun. All right, next, let's talk about mixtures. A mixture is a combination of two or more substances. Notice I said combination. It could just be mixed. There's heterogeneous mixtures, which a mixture that has two parts that are visibly different. I'll give you some examples here in a second. And then there's a homogeneous mixture. A homogeneous mixture is a mixture where the constituent parts cannot be identified by simple observation. For example, let's take a look at Kool-Aid or something like that. You can't look at Kool-Aid when it's all mixed and say, oh, look, there's the dye, there's the sugar, and there's the water. It looks like one new substance. A heterogeneous mixture, on the other hand, you can pick out the different parts. And when I say pick out, that doesn't mean pick out with your fingers. That means you can see it has different parts. That's what makes it heterogeneous. So take a moment and identify these following things as either a heterogeneous mixture or a homogeneous mixture. Birdseed, what do you think? Heterogeneous or homogeneous? Yeah, it's heterogeneous because it's got the two different parts. You can see different things there. What about cookie dough ice cream? Yeah, it's heterogeneous because you can see the different parts. You can see here that we've got some cookie dough parts and we've got some um, and some chocolate parts right there. Let's keep going. How about sugar water? Right now, you would say it's heterogeneous, but once you mix it, can you see the sugar particles in the water? No, like iced tea, you can't. So it would be a homogeneous mixture in that case. How about brass? Brass is actually a mixture of, I think it's copper and zinc. Can you see copper? Can you see zinc here? I can't. It looks like one new substance. So we're going to say that's homogeneous as well. Kool-Aid, I already gave that one away. That's a homogeneous mixture. You can't see the sugar parts and you can't see the flavor parts. This just looks absolutely delicious right now. Um, yeah, there's nothing healthy in there. But you can say that's definitely a heterogeneous mixture because you can see the different parts. It doesn't look like one new substance. Great. Now let's move on to compounds. Compounds are a little bit more complicated. A compound is a pure substance whose smallest unit is made up of atoms, and this highlight and circle this, that are chemically bonded to one another. That is the most important part right here, is that they're chemically bonded. I'm guaranteeing you, I just reviewed the test for our third test. There will be questions about compounds, and I'm going to ask you, why is this a compound and not this? And you would have to say, because they are chemically bonded. That's the key for a compound. They have to be chemically bonded. Can't stress that enough. Compounds have formulas. Here's some examples of compounds and their formulas. Whoops, I'm in the way. We've got H2O, dihydrogen monoxide, C6H12O6, which is sucrose or sugar, um, sodium chloride, NaCl, that's salt, CO2, that's what we breathe out, that's carbon dioxide, and NH4, that's ammonia. So all these things are different compounds, and the little numbers represent how many of each element there is. So we have 2 hydrogens and then 1 oxygen. There's no little number here, so we're just assuming it's 1. Here, like carbon, it's got 6 carbons, 12 hydrogens, and 6 oxygens. So they are all chemically combined to make one new compound. And remember, compounds chemically combined. They can only be created or disassembled by chemical reactions. You can't physically put a compound together. You can't mash it together with a hammer and say, look, now it's a compound. It must be chemically combined. If it's not chemically combined, not a compound. For that matter, you can only take apart chemical compounds chemically. You can't take a compound, smash it with a hammer, use a really sharp knife, and tear it apart. You can't do that. That's impossible. The only way to do that is to chemically take them apart. So this video over here, excellent video. It's only 2.5 minutes, and it tells you all about elements and compounds. I would highly recommend watching that. We'll pause for a second, click on that link, and definitely watch that video. I would show you a brain pop about mixtures and compounds. Unfortunately, I am unable to do that. By doing this kind of lesson, there's nothing in that brain pop video that is necessarily going to be on your test. It just reinforces the idea that compounds must be chemically taken apart and chemically put back together. Okay, so let's talk more about compounds. The constituent parts lose their properties when they bond. I tell my students kind of like marriage in a way, and they're like, "What?" They scratch their heads. Here's what I mean. Oxygen. On its own, oxygen is flammable. Not only flammable, it's explosive. Maybe you've seen people that carry around those oxygen canisters and they have those plastic tubes that go around their ear and then they breathe pure oxygen. It's people often that have emphysema. And then on their oxygen tank, they have these big no smoking signs because that's like a portable hand grenade. If you light that on fire, oxygen is explosive. Same thing with hydrogen. It's explosive. That was what it was in the Hindenburg, which is a huge Zeppelin or a blimp that caught on fire. But when you chemically combine oxygen and hydrogen, it's water. It's not flammable anymore. It doesn't explode. Here's another example. Sodium, it catches on fire in water. You put pure sodium in your mouth, this lights out for you. You're done. Chlorine, deadly. You breathe chlorine gas, you're done. It's both of these things will kill you. But when you chemically combine them, they lose their properties, and now they make salt. It's good on pretzel. So we've got some sodium right here, catches on fire, chlorine, breathe it, you die. You chemically combine them, and now it's safe to eat. They lose their properties. So when I said it's like marriage, you have a new identity in marriage, and that's, I don't know, it's probably too early to talk about marriage to 8th graders, but I say like you have a new identity when you're in marriage. That doesn't mean the old you is not there. You're still there, but now you are part of a whole, um, and it changes who you are. Anyway, here's a video about burning hydrogen and oxygen, and it's a fun video. It's it's interesting, um, but it shows how like hydrogen flammable, oxygen flammable, and then when you put them together, it makes one big explosion, and then it turns into water, and water is not flammable. Anyway, let's keep going. This is just to help us visualize elements and compounds. So let's take a look at our element here. Notice the arrow says there's only one type of atom. Look at this. We've got these red spheres. Let's call those atoms. Only one kind of atom. That makes it an element. There are questions like this on your upcoming test where I'm going to ask you to differentiate between an element, a compound, and a mixture. Take a look at this compound. Each one of these things is exactly the same, and the green spheres are chemically bonded to the purple spheres. Because they're touching, that's what gives them a chemical bond. So all these things are exactly the same, and they're all compounds because we have two different elements chemically combined. So in this case, these are H2, no, they're not H2O molecules, and they're not salt molecules. They're all kind of the new molecule on their own. And then take a look at this mixture here. We've got a compound here, a different compound here, and then a pure element here. So this is a mixture, and it could be a homogeneous mixture or a heterogeneous mixture. I don't know. It just depends. We're looking at it molecularly right now. So one compound, compound A, let's call it, compound B, and then an element. That's what makes this a mixture. It says different elements and compounds. They are not chemically combined. Granted, the purples are chemically combined, and these things are chemically combined, but they're not chemically combined to each other, and that's what makes them a mixture. Okay, I want you to take a moment and look at all these things. I probably shouldn't have given you the answers immediately. I probably should have covered up the answers. But look at what we've got here. And you might even want to pause the video and inspect each one of these things. Here we have an element. How many different kinds of atoms are there? One. Here, how many different kinds of atoms are there? Two. That's what makes it a mixture. And we've got these things that are chemically combined, but those ones aren't. This is also a mixture because we got two different kinds of compounds. How many different kinds of compounds do we have here? One. So this is just a compound. How many different kinds of compounds do we have here? Two. So this is a mixture because there's two different kinds of compounds. Here, one kind of compound, so it's just a compound. This one's tricky. You might say it's a compound. Technically, you're right. It is a compound because these two elements are chemically combined, but it's the same element. So we could say like oxygen, and that's oxygen. So these two things are oxygen, therefore that's both an element and a compound. I would accept both answers for that. This is a mixture. We've got one compound and then two different elements, and here's another mixture. That's just to help us visualize what is an element, what is a compound, what is a mixture. And I realized I should have put a comma up here. I'm sorry for that. Let's go to chemical changes. A chemical change results in the formation of new substances. In other words, a chemical change makes compounds and it breaks compounds. That's what chemical changes do. So they can be represented using chemical equations that consist of reactants, which are the things you put together in a chemical change, and then products, which is what happens after a chemical change. So let's take a look at some examples here. And this is a simplified example to represent a chemical change. You put butter, sugar, eggs, flour, chocolate chips, don't forget some baking soda, and things like that inside a mixture. And then when you bake it, this represents a compound like chocolate chip cookies, even though chocolate chip cookies are not a compound, they are a mixture. That's just representing. So that's a good way to show your students what it might be. Here's a real life example of a chemical change. We've got carbon dioxide, which we breathe out, oxygen, which plants take in. They take in our carbon dioxide, and water. Light energy is the thing that makes the reaction, and what do you end up with at the end? You end up with sugar, you end up with oxygen, and we breathe the oxygen and we eat the sugar. Anyway, we've got just a few seconds left, and then find a link for video number 2 and we'll continue this lesson.